95% of the ocean has never been seen by human eyes, not explored poorly, not mapped roughly, never seen at all by anyone. We have better maps of the surface of Mars than we do of our own ocean floor. We have sent humans to the moon 6 times. We have landed robots on Mars. We have photographed black holes 4 billion light years away. And the deepest parts of our own planet, the places that cover more than half the Earth's surface, remain almost entirely unknown. This isn't a funding problem. This isn't a technology gap that's almost closed. The deep ocean is genuinely, structurally, almost impossibly difficult to reach. And the things we have found in the fraction we've managed to explore are strange enough that most people, when they hear them, assume they're fiction. They are not fiction. To understand why the deep ocean is what it is, you need to understand pressure. At sea level, the atmosphere pushes down on your body with a force of about 14.7 pounds per square inch. You don't feel it because your body pushes back with equal force. The system is balanced. You are fine. Descend 10 meters into the ocean and the pressure doubles. Descend 100 meters and it's 10 times what you experience on the surface. At 1,000 meters, 1 kilometer down, the pressure is 100 times atmospheric. At the deepest point in the ocean, the Challenger Deep in the Mariana Trench, the pressure reaches 1,086 times atmospheric pressure. To put that differently, at the bottom of the Mariana Trench, every square inch of your body would be bearing a weight of roughly 8 tons. Not 8 tons total, 8 tons per square inch. A submarine sent to those depths without proper engineering doesn't leak, it implodes instantly. The water doesn't rush in, the vessel simply ceases to exist as a rigid structure and collapses inward at the speed of sound. We have been to the Challenger Deep exactly 3 times in human history. The first was in 1960, the second was in 2012 when filmmaker James Cameron descended alone in a specially built submersible. The third was in 2019. 3 visits to the deepest point on our own planet in 60 years, but pressure is only the beginning of what makes the deep ocean what it is. Below 200 meters, sunlight disappears entirely. Not dims, disappears. The water absorbs every wavelength of visible light before it reaches this depth. What exists below is a darkness so complete and so total that it has no equivalent anywhere on Earth's surface. No cave, no windowless room, no overcast night comes close. It is the most absolute darkness a human being can experience and still technically be on this planet. In this darkness, at pressures that would kill an unprotected human in milliseconds, life found a way, and the life it found is nothing like what exists above. The anglerfish hangs motionless in the blackness with a bioluminescent lure dangling from its head, a fishing rod grown from its own body, glowing to attract prey in the dark. Its mouth is so large relative to its body that it can swallow prey twice its own size. Its teeth angle inward so that anything caught cannot escape regardless of its size. It cannot choose not to hold what it bites. The geometry of its jaw makes release physically impossible. The vampire squid, despite its name, not actually a squid, turns itself inside out when threatened, exposing a cloak of spines and bioluminescent organs to confuse predators. It lives in what oceanographers call the oxygen minimum zone, a layer of water so depleted of oxygen that almost nothing else can survive there. The vampire squid chose the zone nothing else could tolerate as its home specifically because nothing else could tolerate it. And if not scarier, the barreleye fish has a transparent head. Its eyes, which point upward through the clear dome of its skull to watch for prey silhouettes above, are not the small dark spots on the front of its face that look like eyes. Those are its nostrils. The actual eyes are the 2 glowing green tubes visible through the transparent skull, rotating inside a fluid-filled chamber capable of pointing in any direction. These are not exaggerations. These are documented species that exist right now in the ocean beneath you. But how can these species survive and exist in such places? In 1977, a research submersible exploring the Galapagos Rift, a volcanic ridge on the ocean floor, made a discovery that genuinely rewrote biology. Scientists had assumed, with reasonable confidence, that all life on Earth ultimately depended on sunlight. Plants convert sunlight into energy. Animals eat plants or eat the animals that eat plants. Sunlight is the base of every food chain. This was considered settled. At 2,500 meters depth, where no sunlight has ever reached, they found a thriving ecosystem. Tube worms 2 meters long, clams the size of dinner plates, shrimp, crabs, fish, all clustered around hydrothermal vents, cracks in the ocean floor where superheated water, rich in chemical compounds, erupts from the Earth's interior. The entire ecosystem ran not on sunlight but on chemosynthesis, bacteria converting the chemical energy of hydrogen sulfide into food, forming the base of a food chain that had never needed the sun, had never known the sun existed, had been running in total darkness under crushing pressure, in water laced with toxic chemicals for potentially millions of years. The implications took years to sink in. If life could sustain itself without sunlight in the deep ocean, it could potentially sustain itself anywhere in the universe where liquid water and chemical energy exist. The discovery of hydrothermal vent ecosystems is considered one of the primary reasons astrobiologists now consider the subsurface oceans of Jupiter's moon Europa a serious candidate for extraterrestrial life. We found that down there, in our own ocean, in 1977. And that's only scratching the surface. In 1997, NOAA hydrophones, underwater microphones designed to detect submarine activity, picked up an ultra-low frequency sound from the Pacific Ocean. It was loud enough to be detected by sensors more than 5,000 kilometers apart. The sound was unlike anything in the existing catalog of ocean noise. It didn't match any known geological event. It didn't match any known animal. NOAA named it the Bloop. Pretty strange name, right? And the official current explanation, arrived at years later, is that it was the sound of a large iceberg fracturing, which is probably correct. The characteristics match, the timing works, the science is sound. But for over a decade, nobody knew what it was, and the leading alternative hypothesis, before the iceberg explanation emerged, was that it was biological in origin, something living, something large enough to produce a sound detectable across 5,000 kilometers of ocean. The blue whale is the loudest animal on Earth. A blue whale call can be detected at around 1,600 kilometers. Whatever produced the bloop, if it was biological, would have had to be significantly larger. Nothing that size has ever been found. The bloop remains in the file. The iceberg explanation is the consensus, but the ocean is large enough and dark enough and unexplored enough that the file stays open. The deep ocean terrifies people for the same reason space does. It is a place where the normal rules don't apply, where the things that keep you alive on the surface become liabilities, where the darkness is absolute and the pressure is lethal and the creatures are built for conditions that would kill you in seconds. But space, at least, is empty. The deep ocean is full of things that developed in complete isolation from the world above the surface, full of ecosystems that ran for millions of years without any awareness that sunlight existed, full of sounds that crossed entire ocean basins and left no explanation behind. We are afraid of the deep ocean because it is the closest thing to an alien world that exists on this planet, and it is underneath us right now, still waiting to be investigated.